Hello, pre-calculus students, and welcome to the lesson on exponential functions and equations. And we're going to deal with some word problems here in this example, in this video today. So we're going to start with number 1, and this says, this is commonly referred to as the penny problem. So you win a lottery, you have two options, and this is kind of an unusual lottery. You can either get a lump sum one-time payment of $1 million, or you could get a penny today, a penny tomorrow, 2 pennies the day after that, 4 pennies the day after that, and you just keep on doubling the amount that you get every single day for 30 days. Which option will give you more money after 30 days? Write an equation that describes how much money you have after X number of days. And so we already know that the first choice is going to give you $1 million. It doesn't matter how many days you go on. It's going to be $1 million. So let's start with the second example, and let's look at it first by making a table. Okay, so I'm going to get some fresh paper here. So first, we're going to make a table for option 2. And I'm going to say that, look, this is the day, and we'll start with day 1. Second row, I'm going to put the amount of money added. So on day 1, I get a penny. And then the third row, I'm going to say the total amount of money here. So day 1, I received a penny. In total, I have a penny. On day 2, I get another penny. Total, I have 2 pennies. On day 3, now this is where the money starts to double. I get 2 pennies. And in total, I have 2 and 2, so that gives me 4 pennies. On day 4, and this is tedious, so I'm going to go a little bit quick through all of this here. Day 4, I get 4 pennies now, and in total, I have 8. Day 5, I get another 8, so now in total, I have 6. And on day 6, I get 16 pennies. In total, I have 32, and so on until we'll go to the 7th day. We'll go a full week. So after a full week of doing this, I got 64 cents. Seems a lot smaller than $1 million for sure. So this is going to proceed and continue on until day 30. Okay? And we're going to say day 1 is today. So if we use x as the day number and f of x as the total amount of money, and you can kind of see that here everything doubles. If you look at the total amount of money you have every single day, this is increasing by 2, then it's increasing by 2, then it's increasing by 2, then it's increasing by 2, and so on. This pattern is going to continue forever, for 30 days. So that leads me to believe that the base of this is an exponential function. And it's going to have a base of 2. So it's going to be y equals something times 2 to the x, because every single day I'm multiplying by 2. Well, the initial value seems like it should be 0.01. And let's see if this works. Let's say if I put 1 in here, so we'll do some checking right here. Does this equation really work? So we'll check. When x equals 1, y equals 0.01 times 2 to the x, which is 0.01 times 2 to the first power, which is 0.02. So this actually fails, right? It should be equal to this number, but it doesn't work. And the reason it doesn't work is we need to adjust things a little bit. We really need to shift everything down by 1. So this really needs to be 0.01 times 2x minus 1. Okay? This seems like it works better because if you substitute 1 into this, check now, okay, x equals 1, y equals 0.01 times 2 to the first minus 1, which is that. And we know that anything to the 0th power is always itself. So this is this is a good answer. It actually works. Okay. We'll try one more time. What if x equals 3? Well, y equals 0.01 times 2 to the 3rd minus 1, which is 2 squared, and that's equal to 0.04. Okay, so yeah, it works again. So this equation looks like it works, and it's much better. Okay? So after 30 days, or on the 30th day, the total amount of money that you have is y equals 0.01 times 2 to the 30th minus 1, which is 0.01 times 2 to the 29th power. And I don't really know this off the top of my head, so I'm going to use a calculator. 0.01 times 2 to the 29th power. And that gives me that number. That looks like $5,368,709.12. There you have it. So clearly, option 2 is your better choice here. Now, a good thing about solving word problems is there's multiple ways to do this, and I want to show you another way. Okay? And you may look at this and you may think it's useless. I don't know. You might find it useful. In either case, I'm still going to show you this just so that you see that there's multiple ways to dealing with these problems, and there's multiple solutions or multiple ways to the correct solution. So I'm going to bring this back here, and I'm going to write it this problem another way. Instead of starting with day 1, I'm going to start this is another way, another method. I'm going to start with day 0. This is today. So day 0, you have 0.01. This is the amount of money added, and this is the total amount of money, and it's the same thing. Okay, day 1, 0.01 added, 0.02 total. I'm just going to fill all of this 2, 3, 4, 5, 6. So instead of going from 1 to 7, I'm going to go from 0 to 6, and this pattern is going to continue to the 29th day. Okay, so instead of going from 1 to 30, I'm going to go from 0 to 29. And I'll fill this in relatively quickly here. You can hit pause once I'm done writing this, or you can try to fill this all in yourself, because you can certainly do that. And this is going to go on to the 29th day. Well, now the function f of x equals 0.01 times 2 to the x. Now this in fact does work. See, up here, it doesn't, this function here did not work when you're going from 1 to 30, but this function right here works perfectly well if you're going from 0 to 29. So I'll show you. What if you have f of 0? On the 0th day, you get 0.01 times 2 to the 0th power, which is 0.01. What if you had f to the 4th? And mind you, the 4 here is really the 5th day. 0 here is the 1st day, depending on how you want to call this. Okay? So f of 4 is 0.01 times 2 to the 4th, which is 0.01 times 16, which is 16 cents. So it does match up, and this function works. Okay? And now we can solve this problem. Instead of going to f to the 30th, we're just going to go f of 29. And it's going to give you the exact same answers that you got before. $5,368,709.12. Okay? So it's the exact same thing. It's another way to deal with this problem. And I'd like you to keep this in mind. You might be thinking, well, what's the point? Why do we have to solve this multiple ways? Just keep this in mind. For a simple problem, it might not make much of a difference. Once we get to something complicated, the difference may be significant in terms of how quickly you can solve it, how easily you can solve it. Okay, so thank you for watching this video. Have a wonderful day. Make sure you continue watching all the other videos. If you notice from the sheet that I had here, there's about 17 problems here, and we are going to do every single one of them together.